Okay, so 11.7 is on these area ratios. So if you just read what it says here. If two figures are similar and their scale factor is A to B, then their perimeter ratio, don't you already know what it is without me telling you? It's A to B, right? The ratio of the sides of the figures is the same as the ratio of their perimeters. So if the scale factor is 1 to 2, the ratio of the perimeters is 1 to 2. It's the same. However, if you compare the ratio of their areas, what do you suppose that will be? It's A squared to B squared. Yeah. So that's it for the notes on that section, but let me show you kind of putting this into play. So, real quick, if we look at page 459, I believe it is. Yeah. So, you're going to be asked, do I ask you to do this one? No. So, let's do this together. So, there's a chart here. They give you the scale factor, and then they're asking you, all right, if the scale factor is 1 to 4, what would the ratio of the perimeters be? 1 to 4, it's the same. Right? Scale factor and ratio of the perimeter are the exact same. But then the ratio of the areas would be 1 to 16. You just have to square them both. So let's try this one. 3 to 2, what would go here? That's it. Okay, let's get fancy. Ooh! Now, a little trick here.
You sound like a cult. Oh, wait, you're recording. Oops.
It is what it is. 9 to 5, what would go up here? And this would be? Right. Now, for whatever reason, when we get to these ones, I don't know. I was going to say all hell breaks loose, but that's too cult-like. So,
Can I leave?
if this is the ratio of my areas, what must my scale factor have been? 5 to 1. That's it. So if you're ever given the ratio of the areas, ladies and gentlemen, you just have to take the square root of each to get back to the scale factor. So this one would just be 3 to 8 and, oh, sorry. This last one. So this would be square root of 2 to 1 for both of these. Does that make sense? So let's just try. Let's look at one like number. Yeah, okay. If we look at number 10, pretend you don't see the answers. It says, the areas of two circles are 36 pi and 64 pi. What is the ratio of their diameters? Well, if the ratio of the areas is 36 pi to 64 pi, first of all, I would reduce that. So pi's are going to cancel out, right? 36 over 64, what does that reduce to? 9 over 16? Okay, so there's the ratio of my areas reduced. So then, what would the scale factor be? 3 to 4. And wouldn't the scale factor be the same as the ratio of the diameters? Yes. How about the circumferences? What would the ratio of the circumferences be?
Wait.
Still 3 to 4, because isn't circumference the same thing as perimeter?
Yes.
Yes.
How is 9 to 16 the same thing as 3 to 4?
It's not. It's A squared to B squared.
Oh, that's the area.
Right. So here's, if they give you the ratio, or if they give you the areas, reduce, and then you take the square root of each to get back to the scale factor.
The positive square root, or does it not?
Yeah, positive. Yeah. We're always sticking positive here. Okay? So that's pretty much it for 11.7. So